Hi everyone, in this video segment we are going to be discussing how hybridization state can affect acidity and basicity. It is the case that sp hybridized atoms have, in general, more acidic hydrogens than sp2 hybridized atoms, which in turn have more acidic hydrogens than sp3 hybridized atoms. Okay? Hybridized atoms with greater S character will be effectively higher electronegativity than atoms with less S character. Remember, when we thought about our different hybridization states, sp hybridized atoms had 50% S character, sp2 atoms had 33% S character, and sp3 atoms had 25% S character. So here we see increasing acidity of the hydrogens bonded to these carbons because of hybridization state. The sp hybridized carbon has the most S character. It is effectively the most electronegative of the carbon atoms in this series. Okay, and hybridization state will best differentiate the acidity of acids. When you're looking at the atoms being the same, like here they're all carbon atoms, but they're differing in their hybridization state, sp3 versus sp2 versus sp. All right, and notice the difference in pKa values. When you look at a proton bonded to an sp3 carbon, approximate value is around 49. When you look at now having that proton on an sp2 carbon, we drop down a little bit, but it's not a huge substantial difference. However, that difference of going from sp2 to sp is pretty substantial. This terminal alkyne hydrogen bonded to the sp carbon of the triple bond here has a pKa around 25 or 26, depending upon the resource that you look at. Okay, that's interesting, right? That's a pretty substantial drop. Just to give you a reference molecule here, ammonia, NH3, we have a proton bonded to an sp3 nitrogen. Its pKa value is around 36. So we actually see that the terminal alkyne is more acidic than ammonia or some type of alkyl amine, right? These would be approximately around 36. So what that means is that a carbon that is sp hybridized is effectively more electronegative than a nitrogen which is sp3. But that nitrogen which is sp3 hybridized is more electronegative than a carbon that is sp2, and the carbon that is sp2 is more electronegative than a carbon that is sp3. This understanding right there can benefit you later on in the course. Now, given that an sp hybridized atom is effectively more electronegative, let's think, what does that then mean for the conjugate bases? Let's deprotonate each of these acids and look at the conjugate bases where the negative is now residing on the carbon atoms from which the proton was taken. We have an We have an sp hybridized carbon bearing the negative, an sp2 hybridized carbon bearing the negative, and an sp3 hybridized carbon bearing the negative. This sp hybridized carbon is going to be the most electronegative, and therefore it is the most accommodating of that negative. It will be stabilizing it. It will stabilize that negative charge to the greatest extent. The lone pair is located in an sp orbital. The lone pair here is located in an sp2 orbital, and the lone pair here is located in an sp3 orbital. And that lone pair is best stabilized in the sp orbital. We would say that CH3- is the least stable anion in this series. If it is the least stable, it is the strongest. If it is the strongest base, then it has the weakest conjugate acid. Again, we'll use stability of the conjugate base to then make a comparison in the acid strength. Okay, so you might pause your video here and just jot all this down. Okay, I'm going to clear this part of the screen real quick just to make things less visually cluttered, and I want to give you one more example. You might look at a molecule here called pyridinium. We've got a nitrogen that is positive, it's a nitrogen atom, and we might compare that to a nitrogen atom that is also positive, but it's sp3. So here we have a comparison between an sp2 nitrogen and an sp3 nitrogen. And if we wanted to think about the relative acidity, well, we are looking at a nitrogen atom, right? So atom is the same, but the hybridization state is different, and therefore the more acidic species is going to be the one that is the sp2 nitrogen. That is a stronger acid, okay? And here we have the weaker acid, and this is based upon hybridization state. So hybridization state is a factor when the atoms are the same, but their hybridization state is differing. And the sp hybridized atom has more S character than the sp2, which in turn has more S character than the sp3, and we see increasing acidity because we have increasing effective electronegativity of the atoms and the ability to stabilize that negative charge when we have increasing electronegativity based upon hybridization state.